Assalamualaikum. Now I'm going to deliver my lecture on transportation models. In this lesson, I will explain about initial solution by using three different methods: Northwest Corner Rule, least squares method, and Ogle approximation method. Once we found the initial solution, it can be optimized by using modified method or MODI. Uh, to begin with, we need to understand the purpose objective of this lesson, where the purpose of transportation model concept is to minimize or to find the lowest transportation and production cost as well. If you want to deliver products or units from several points of supply sources to another several points of demand or destination. Consider I have a production area in Ipoh, Taiping, and Manjung, and for each of this area, there is a certain capacity weekly production in kilograms. And for each production area, I need to send to different market locations such as in R, S, T, and U. In R, the weekly demand is 280 kgs, S 200 kgs, T 360 kgs, and U is 480 kilograms. To send from the production area to each of these market location, I need to consider the cost involved, and the cost is shown in this table, where the cost to supply from Ipoh to destination R is 28 ringgit, from Ipoh to destination S is 18 ringgit, until from to supply quantity or units from Manjung to U is 36 ringgit. Therefore, the network for the transportation problem is shown here. For example, from Taiping, the capacity is 420 kgs, will be sent to RSTU, and same with Manjung with the 600 capacity of production. This quantity need to be allocated to different market RSTU, and same goes to Ipoh with this number of supply need to allocate to R, S, T, and U. Recall my second slide. I give you three different tables: production, market location, and the third table is the cost. If I want to find the minimum cost by using initial solution, which is I will explain using Northwest Corner Rule as the first method, I create a new table, which is, if you observe here, there are values in the middle of the table: 28, 18, 32, and so on. This value refer to the third table, and the value for 280, 200, 360, 480 refer to the second table, and the values in the supply column 300, 420, 600 refer to the first column. And now, how to start? The starting point is the northwest corner of the table with maximum quantity allocated to the cell. Okay, meaning that I need to choose this column as my starting point. This column is the most upper left cell. And if you observe here, the maximum supply is 300 and the maximum demand is 280, meaning that the maximum unit I can put here is 280. Automatically, the column for R is fulfilled. Then we move to the next column. What next? If the demand for the first cell is satisfied, then move horizontally to the next cell in the second column. Maximum value already put here for column R, and for column S, the maximum supply is 300. We already have 280 here, meaning that we can put another 20 unit here. So 280 plus 20, it makes the supply for the first row is fulfilled. Then we can move to another row. Continue from the previous slide. Column R is satisfied and row IPO also satisfied. Then we move down to the first cell in the second row, meaning that second row here is row typing, and we cannot do anything in this cell, and we move to the next cell, which is the second cell here, and we need to determine what is the available unit should be put here. And since 20 unit already put in this cell, meaning that we can have another 180 unit here. So now it gives the total of quantity 200 if we add these two, and column S also satisfied. We move to another cell. Since for this typing, row typing, we have capacity of 420 unit. Now 180 unit already put here, so we can have another 240 unit. And if we add 180 plus 240, the total is 420, meaning that row typing is satisfied. So we move to the lower row, which is row Manjung, and we can see here for row Manjung, the maximum supply is 600. Uh, Now we must determine what's the value here. 360 is the demand required in T, meaning that we have another 120 that we can put here. So the total for column T, 240 plus 120 is 360. The last cell for Romanjong, since we already put 120 and the balance that we have is 480. 120 plus 480, the total is 600. Satisfied. And the total for column U is also 480. Satisfied. And when should we stop? We need to check if demands and supply are satisfied. Here we can see that for column R, S, T, and U, all are satisfied. And we check the row IPO, typing Manjung. Yes, we can see that all the rows are satisfied. Then, what is the total transportation cost? The formula is unit transported multiplied with per unit cost. And these are the calculation. 280 times 28. We refer to this cell 280 multiply 28, and 20 times 18, the second cell, 20 times 18, and until the last cell, 480 times 36. 480 times 36. Then the total transportation cost is 34,120 ringgit.